Hi, welcome to Industrial Training Institute Learning Corner. I am Kanjo Hussain. Welcome to everyone. And the last class we have studied what is temperature, what is heat. Now we are going to study about the melting point of substance, boiling point of substance, and the different types of temperature measuring instruments such as thermometer, mercury thermometer, pyrometer, optical pyrometers, and other one is the functioning of thermometers, and what is the optical pyrometer, and heat conduction, convection, and radiation, etc. And the first topic is what is melting point of substance. The melting point means the molecules or atoms in substance gain energy, the heat energy, and the frequency of the vibration gradually increased, and it is independent to move, and it is able to move from its place. So the body changes its shape, that become liquid. The melting point is the body changing from solid state to liquid state. In solid state, molecules or atoms are immobile or unable to move from its place. But when it is heated, it can move from its place, and they become liquid form, and the molecules are able to move and attain the shape of the container where it is placed. Example, the melting point of ice is 0 degrees Celsius at 1 atmospheric pressure, and when given heat, that means it is given 80 calories per gram to change the 1 gram of ice at 0 degrees Celsius to 0 degree water. This is what is called the melting point. Different substances having different melting points. So aluminium has melting point 658 degrees Celsius or 660 degrees Celsius. And approximately the melting point of copper is 1083 degrees Celsius, and iron has melting point of 1550 degrees Celsius. So the melting point is the temperature at which the substance in solid form changing into liquid form. When it is given heat, the attractive force among the molecules or atoms decreased, and it is able to move from its place and become liquid. And next point is, what do you mean by boiling point of the substance? The boiling point is the substance, when it is given heat, it can move freely after getting the energy. It can move entirely freely, or the attractive force among the molecules are very, very less, and it can move entirely random, and it can move any directions without any governing. So this form is known as gaseous state. The gaseous state, the attractive force among the molecules or atoms are almost nil or very feeble. The van der Waals force is very feeble, attractive force is very, very less, the molecular energy is somewhat more. This state is known as what? This is known as gaseous state, that is changing from liquid state to the gaseous state. And next topic is, what are the temperature measuring instruments? The commonly used temperature measuring instruments are thermometer, pyrometers. The pyrometer is again classified into two: thermocouple pyrometer and optical pyrometer. In thermometer, the construction is there will be a metallic bulb inside which there is mercury. And above the metallic bulb, there will be a vacuum hole which is condensed with the glass tube. On glass tube, there will be a graduation. The graduation can be degree Celsius, degree Reaumur, or degree Fahrenheit. When the temperature of the body is to be measured, the metallic bulb is made contact with the body, and after getting the heat, that means when it's made contact, the heat flows from high temperature to low temperature, and the metal or mercury getting heat from the body, and it expands and rising through the vacuum hole, and the graduation is there to read the temperature. This is called mercury thermometer, which is in triangular shape, so that we can visualize the indication of the mercury clearly. This is what called mercury thermometer, which is the 200 degrees Celsius thermometer or there, and the more the temperature is to be measured, the possibility of the more error is that. That is the conventional error in mercury thermometer, which can read the mercury thermometer can read 200 degree Celsius thermometer, more or less read inaccurate. Above that, there will be the possibility of the small errors. And the next one is what is pyrometers? Pyrometers are used to measure the temperature in higher degrees. For example, thermocouple pyrometer, which can read about 4,000 degrees Celsius can be measured, even though they form of flames. High temperature flame that can be measured using thermocouple pyrometer. The principle is the two different metallic wires are taken and joined in two ends. One is placed in cold junction. Cold junctions, we prepare the cold junction by making brine. Brine solution means the ice at -4 degrees Celsius is melted by mixing salt, that means potassium chloride or sodium chloride, etc. The ice will melt. At -4 degrees Celsius, it becomes liquid form. That is placed, one junction is placed in cold junction. And other junction can be prepared to keep in hot junction. That means the 100 degrees Celsius, or that means in 1000 degrees Celsius, there will be preparations, and the fire, and that means some porcelain are placed, so that the metal will not directly gain the direct heat, and there will be some preparations to withstand the melting of the metal joint. And when it is kept in hot junction, what will happen? The EMF is produced between two different metal wires that can be copper and iron. EMF is induced. EMF induced is directly proportional to the temperature difference. If more is the temperature difference, more EMF is induced. And it can be red according to the voltage produced. This is the principle of thermocouple pyrometer. And another one is optical pyrometer. This one is without touching a body, we can measure the temperature of a body. The principle is there is a relation between the color of the body, that means hot metal, color of the hot metal and the temperature of the body is greatly related. Example, when pure iron is heated, it gets red hot or dark red. That is about the lower critical temperature begins, there's 710 degrees Celsius. After further heating, the metal is again heated, the temperature rises up to 910 and above, the color gradually changing into pale color. When it goes to pale, the temperature is increasing. That means, so that there is that means in some metals it is getting the dark yellow. That is above 1000 degrees Celsius. There will be color variations are there according to the temperature changes. So in this metal, if we prepare the filament of a bulb, and when it's made glow using electricity, the color of the filament and the color of the hot metal, if perfectly matches, we can assure what will be the temperature of the hot metal without touching the body. That's what is called the optical pyrometer. In optical pyrometer, we observe the color of the filament, what we glow, and the color of the metal, if completely perfectly matches. The current in electric circuit is measured according to that temperature can be calculated. This one is called optical pyrometer. So this is the principle of the optical pyrometer. Again, the other topic is the conduction, convection and radiations. Conduction of heat, that means the heat transmission in solid, that is known as conduction. That means because of the vibrations of the atoms or molecules, if heat is transmitted in solid, that is known as what? Heat conduction. Example, if you heat a copper rod at one end, heat is transmitted to other end. That one is called heat conduction. The statement is because of the vibration of the copper molecules gradually transferred from one end to other end. This one is called heat conduction. And next one is heat convection. The heat convection means because of the movement of the molecules, when the heat is supplied in liquid, there will be movement of molecules. The movement of molecule is due to there will be the density difference between them. When heat is supplied at the bottom of the container, the liquid gets heat and temperature rises, correspondingly the density decreases. As temperature rises, the liquid expands and the density decreases. At the top level, the temperature is comparatively less on top and the density of the liquid is more, and the high denser part molecule, the water or liquid comes down to the bottom of the container, and the molecules or liquid, it rises to top because of the expansion, and when the high density liquid comes down, automatically the low denser liquid goes up. This circulation happens. This is one is called the movement of the molecules of the body liquid. The heat transmitted is known as what? It is known as heat convection. And the last point is heat radiation. Heat radiation means heat is transmitted in vacuum or in air. That's known as what? Heat radiation. The sun, the heat from sun reaches to earth because in the medium of vacuum, there is no medium, there is no air, there is no substance. The heat can enter to the earth from the sun through vacuum. This one is called heat radiation. And the heat radiation can be with respect to the temperature difference between the heat resource and heat receiving source. Heat receiving body should low in temperature and heat supplying source must be high. Then only heat will transfer from high temperature to low temperature. And heat receiving body, if it is having more area, more heat is absorbed. And the color of the body is, if it is black, that absorbs the heat. That absorbs more heat compared to the white body. Because white substance, white surface reflect the heat as well as light. But black body will absorb the heat as well as light. So the black body can absorb more heat compared to white. This one is called heat radiation. So that heat radiation can be more because of the more temperature difference, more area of receiving, and because of the color. The three things which will calculate the amount of heat is transmitted in radiation. So I hope you have understood all these topics. You can subscribe this channel. Thank you very much.